Introducing AgentSeer, our agentic AI observability and safety platform. At its core, it provides a dual knowledge graph to track both agentic actions and AI components. AgentSeer enables a comprehensive observability to stakeholders to understand what's happening inside complex agentic AI systems, which can often feel opaque given the complexity of their operations. As a demonstration, our testbed Agentic AI features an e-commerce assistant, helping store owners with advanced sales analysis. You can see it provides revenue calculations, product insights, and other detailed analyses in real time. It integrates store data, semantic knowledge-based search, and the code interpreter for complex analytics. Behind the scenes, each user query triggers a chain of operations, which AgentSeer breaks down into individual actions. This gives full visibility into the AI's decision-making and execution. Each action is represented as a node, with edges showing the flow of context. This flow is intuitively visualized by highlighting edges from a selected action to all actions that consume its output.
AgentSeer outputs the action graph in a structured JSON format. This dataset serves as the foundation for our Agentic-level red teaming pipeline. In this demonstration, we ran jailbreaking attack tests across 29 actions extracted from the testbed, applying 3 distinct message types with 2 injection strategies each, resulting in 2,340 targeted attack tests. Using LLM as a judge, we then calculate the attack success rate for each action, capturing the foundational action risk with precision. These results are then expanded into a comprehensive safety profile, capturing not only systemic risks across actions, but also component-level risks, such as tool latent risk, memory exposure risk, and agent risk. Finally, these findings are seamlessly integrated back into AgentSeer's visualization, transforming safety data into clear, actionable insights within the observability platform.
Each node shows information of its model, agent that executing it, and color-coded safety metrics from our agentic-level jailbreaking evaluation. On top of that, the detail panel provides deeper insights. Detailed safety metrics, such as blast radius and systemic risk, tell how wide and risky each actions might affect the entire system. Detail of each component used in both input and output of each action are also recorded in here, as well as memories it writes into, giving detailed risk propagation information. Every action records its inputs and outputs, from the system prompt, user query, agentic chain operations, tool messages, to the final AI output, giving complete traceability.
Now, let's dive into the component graph view. Here, each agent, tool, and memory is visualized along with their interrelations. Each agent node is color-coded by its risk score, and when clicked, highlights edges connecting it to related tools and memories. Memory nodes display both their name and associated risk information, while all tools available to an agent are also visualized, complete with risk scores and highlighted connections. This gives a comprehensive view of the relationships between components for all agents extracted from the testbed system. The detail panel provides further information, including the LLM used in the agent and the full system prompt. The relationships between actions and components are also shown. Clicking on an action node reveals the specific components involved, the executing agent, the memories read or written, and the tools used in its context or output, such as the next tool to be called. For example, here we click on Action 3. We can see it is executed by the Revenue Analyst agent, which calls the Python code interpreter tool and writes to the agent's memory. We can also explore the inputs to Action 3 to understand which components are involved in its context. This view gives you full transparency into how each action interacts with the system, making it easy to trace behavior and assess risks at every step. That concludes our demonstration of AgentSeer. We've shown how it makes agent behavior transparent across both the architectural components and temporal actions, allowing you to trace, analyze, and assess risks at every step.